All right, hey guys. This is homework number 3, unit conversions part 2. Very exciting stuff. I'm very sorry if you're doing your homework on the last day before it's due and now you have to listen to me talk through both sides. So I'll try to limit my talking, but we'll just get right into it. So these are from the IB textbook for math studies, and these are some of the example problems. So let's jump right into the first box. So how many meters are in 50 millimeters? So let's start with what we know. We know that we have 50 millimeters. If we're starting with a unit on the top, we need to move that unit to the bottom to make sure that they cancel out, and we're going from millimeters to meters. So just to double check, we can cancel the millimeters up here with our millimeters down there. Good, so we match top to bottom. Now I need to think about how many millimeters are in 1 meter. And I know that there are 1,000 millimeters in 1 meter. And I also forgot to put my 50 millimeters over 1, so please excuse me. So if you want to set it up like that, that's totally fine. So we're going to take our numerator divided by our denominator, so if we multiply our whole numerator together, we have 50 times 1, which is going to be divided by 1 times 1,000. So we're going to have 50 divided by 1,000, which will give us 0.05 meters. Normally right now we talk about whether this answer was reasonable or not, but I'm going to actually answer the next question so that we can illustrate why each of these answers is reasonable from themselves. Because in this one, we're going from how many millimeters are in 50 meters. So we're going from meters to millimeters. In this one up here, we're going from millimeters to meters. So we're going to have very different answers in terms of the number of zeros that we're going to have in our and their corresponding decimal place values. So we're going to start with 50 meters in this case, 50 meters over 1, just so we can line up our numerators and our denominators. If we have meters on the top, we need meters on the bottom. And we know that we're going from meters to millimeters, so we're also going to do millimeters on top. Double check, make sure those cancel. Good. So now we need to figure out how many millimeters we have in a meter. We know that there are 1,000 millimeters in 1 meter. And in this case, I'm going to just multiply my numerator because my denominator is 1. So 50 times 1,000 is going to give us 50,000 millimeters. Good. So let's talk about this one for a quick second. So we went from 50 millimeters to meters, and we ended up with 0.05 meters. When we went from 50 meters to millimeters, we ended up with 50,000. So notice that we started with the same number, and it was just our units that were different, and we ended up with 2 very different answers. So in the one where we started with 50 millimeters, we ended up with 0.05 meters. And that makes a lot of sense, right? Because meters are bigger than millimeters. So that means if we have a certain number of millimeters, it's going to be a smaller amount of meters. Thinking about this one, we start with 50 meters. That's like 50 meter sticks. If we're thinking back to what we did on class in our first day, we have to multiply that by 1,000 millimeters because there's a lot of millimeters. There were 1,000 millimeters in each of those meter sticks. So if we think about how many little tiny tick marks we had on each of those meter sticks and we had 50 of them, 50,000 makes a lot of sense. So that's a good way to think through whether our answer makes sense at the end of when we do our unit conversions. So let's move on then to our external assessment style problem. And this is also unit conversions, but it's a little bit different. So we know that a cubic container has sides that are 1.5 meters long. The length is 1.5 meters, the height is 1.5 meters, and the width is 1.5 meters. So we're going to find the volume of the container in meters cubed, which makes sense because we are talking about meters in the first place. So first we have to know our formula for volume. Volume equals length times width times height. That can be found on your formula sheet as well, which is on Google Classroom. So volume is going to equal length, which is 1.5 meters, times height, which is 1.5 meters, times width, which is also 1.5 meters. Good. So this is kind of cool because it said to give us our answers in meters cubed. And look, we have 1 meter times 1 meter times 1 meter here. Meter times meter times meter is meter cubed. Then we move on to our coefficients. So we have 1.5 times 1.5 times 1.5. and that gives us 3.375. So there's a decimal point right here, 3.375 meters cubed. Now the next part, it says give your answer to part A, and it's going to be centimeters cubed. Centimeters cubed. So if you're looking at it, make sure you add in that cubed to your answer. So we start with our 3.375 meters cubed. And if we have meters cubed on the top in our numerator, we're going to want to have meters cubed on the bottom in our denominator. And then we know we're converting to centimeters cubed. So we're going to make sure we want that in our numerator. So the cubes can be a little bit confusing. We are going to pretend that we're just going from centimeters to meters, right? Because if they're both cubed, that means that it's going to be the same conversion factor. So we have 100 centimeters cubed in 1 meter cubed. So then we are just going to take our 3.375 times our 100, and that will give us 337.5 centimeters cubed. And just to double check to make sure we did this right, we can cancel our meters cubed because we put it on the top and the bottom. And also, we have a bigger number than what we started with because centimeters are smaller than meters. So our next part is decide whether 4,000 liters of water can be poured into the container. Justify your answer. And the hint is it's 1 centimeter cubed equals 1 milliliter. So let's make sure to add that out so we know it's 1 milliliter. So the way that I decided to approach this problem, there's a couple of different ways you can do it, but I want to find out how many centimeters cubed are in 4,000 liters, because then I can compare it to our answer from part B. So I'm going to start with 4,000 liters, which is what we know. So I know if I have liters on the top, I'm going to need to do liters on the bottom. And then this is the crucial relationship that we need to know, is this hint, 1 centimeter cubed equals 1 milliliter, because I have no idea how many liters are in a centimeter cubed, but I do know how many milliliters are in a liter, and I do know that 1 centimeter cubed equals 1 milliliter. So I'm going to go from liters to milliliters. If I have milliliters on the top, I'm going to do milliliters on the bottom. And I know that milliliters, 1 milliliter equals 1 centimeter cubed. So I can even fill in the numbers for that right now too. So does that make sense? We have liters that canceled with liters, milliliters cancel milliliters, and we're left with centimeters cubed, which is what we're looking for, so we can see if it will fit in the container with the volume that we found in part B. So let's fill in the numbers. How many milliliters are in 1 liter? I know that there are 1,000 milliliters in 1 liter. So now I've filled in, and I forgot to put this one over 1. So now I have all of my numerators and denominators filled in. So let's do some math. Looking at this, we see that everything in our denominator is 1. So that means I can just multiply across with my numerator. So I'm going to take 4,000 times 1,000 times 1. So 4,000 times 1,000 is going to give me a lot of zeros. So 4 with 6 zeros, which is going to be 4 million centimeters cubed. So can my 4 million centimeters cubed fit in a container that only holds 337.5 centimeters cubed? No, there is no way. So I'm going to say no, the answer in part B is greater than the answer in part C. So I'm just going to say here B is smaller than C. And if you're watching this video, if you want to explain it a little bit better, that would make me very happy. But for the sake of space, that's just what I'm going to write here. But once again, to explain why that happens, 4,000 liters is the same thing as 4 million centimeters cubed. And 4 million centimeters cubed is not going to fit into a container that only holds 337.5 centimeters cubed. If you have any questions about this one, you can come talk to Miss Avra or me, and we would be more than happy to talk you through it too. But this is just a little sneak peek about how to do it if you're sitting at home and you are confused before the homework quiz tomorrow. So let's look through now to the ACT problem. So let's read this one. Akiko's average heart rate is 70 beats per minute. In scientific notation, how many times would her heart beat in 24 hours? So let's write down what we know. We know that her average heart rate is 70 beats per 1 minute. And we want to know how many are in 24 hours. So I'm going to go from minutes. Ooh. Going to move that up so you guys can see. Good. So 70 beats per 1 minute. I want to know how many times her heart would beat in 24 hours. So we're going to go from minutes to hours. And I don't know about you, I don't know off the top of my head how many minutes are in 24 hours, so I'm going to do a conversion from minutes to 1 hour. I know that there's 60 minutes in 1 hour, and I know that I'm going to then multiply by 24 hours because that's what it's asking for. So, once again, I see that everything in my numerator is a different number, but everything in my denominator is a 1. So I'm going to multiply across my numerator. And that's going to give me another big number. So let's see what this one is. I had 100,800, like this. And that would be beats in 24 hours. So let's see. If I'm looking at my answers, we see that all of these are in scientific notation. So that is really exciting because guess what? This was a unit conversion and scientific notation problem. So 2 of the things we've been working on. So I ended up with 100,800. So we can do this 2 ways. Either we can convert this into scientific notation right away, which is what I'll do right now. So let's think about this. So we have our decimal point back here at the end because it's 100,800 beats per 24 hours. So let's see, where would I want my decimal point here? I want it to come right here because it's after the first digit that's our non-zero. So let's count. We have 1, 2, 3, 4, 5. That's how many times I move my decimal place. One more time. 1, 2, 3, 4, 5. So that gives me 1.008 times 10 to the 5th. Is that one of my options? Yes, that is K. So we have 1.008 times 10 to the 5th beats. The other way you can do it, which is how I did it at first, was I looked at this and saw it was 100,800. And there's only 2 options that use those the same digits. So I eliminated F, G, and H because that doesn't give me numbers that correspond to 100,800. And then when we're left with J and K, we just think about how many times we move our decimal place, and we did move it 5. So that's another way to kind of approach this problem. So let's move on to number 5. So we have Janice's average heart rate is 70 beats per minute. At this rate, how many times to the nearest 1,000 does her heart beat in 7 days? So let's start again with what we know. We know that her heart beats 70 beats per 1 minute. So, and we know we're trying to end up with days. So I'm going to try and convert minutes into days. Well, I have no idea how many minutes are in a day. So I'm going to go from minutes to hours and then hours to day because I know that there's going to be 60 minutes, making sure to match up my units here. 60 minutes, minutes on top, minutes are on the bottom over here, so I put minutes on top over here, to 1 hour. Moving on, I have hour on the bottom. I'm going to do 24 hours are in 1 day. And I made sure that hours were on the bottom here and on the top here. Good, so these will cancel. So when I do that, I will get, let me just type this into my calculator really quickly so you guys don't have to at home. 70 times 60 times 24. That gives me 100,800, which is weirdly the same number on the other side, but that's okay. I could have just looked over there. Beats per day. Am I done? Well, first of all, that's not an option that we see in the multiple choice, so we know that I'm not done. I'm also not going to write it like that. Beats per day. I'm going to do beats per day this way. Well, we know that we needed to talk about how many times her heart beats in 7 days, so I'm going to do times 7 days. So let's see. So days were on the bottom over here, so we're going to have days on top over here. So that times 7 gives us 705,600. Let me just scooch that up a little bit so you guys can see. 705,600. That is not one of the exact options we see, but up here it says to the nearest 1,000. So this is our thousands place. This is now rounding, which is something else we did on the first day. So that's also super exciting because in these 2 ACT problems, we've done basically everything we've done in class so far, which is amazing. So to round to the thousands place, I'm going to look at this digit before it and see if I would round up or down. And since 6 is greater than 5, I know that this is going to round up to 706,000, which is one of our option choices, which is D. Again, if you have any questions on this, please come see me or Miss Avram. We'd be more than happy to talk about it, but hope that you guys found this video helpful if you were having any problems or had any questions on your homework. See you in class soon.